I wanted to compare and contrast for you r cosine theta and y equals cosine x. So let me zoom in a little bit here. So, oops, maybe too far. 5 cosine of x looks like this. And at 0, you're at 5. At pi, you're at -5. And then at 2 pi, you're back at 5 again. And it's a periodic function. Obviously, it keeps going on forever. But it directly relates over to the polar coordinates. Also, pi over 2 is 0. 3 pi over 2 is 0. You can see how it goes negative here and so on. Coming over here, if I'm at an angle of 0, I'm at 5. And then, just like I said, if you go around to 2 pi, you're at 5 again. If you are at pi over 6, let's say, that's about a little less than 4.5, I'd say. And if you come over here to pi over 6, it is also a little less than 4.5. And then if you look at pi over 3, it's about 2.5. Well, actually, it's probably, yeah, it's right at 2.5. So I come over here, pi over 3 is here, and it's right at 2.5. So the question is, why isn't there anything in quadrant 3 or quadrant 2 or quadrant 3? Well, because if you look at 5 pi over 6, let's say, and I come over here and I look at the cosine wave, 5 pi over 6 is right here. And this is about -4.5, maybe a little bit higher than that. So if it's 5 pi over 6 here on my polar grid, and I'm going in the negative direction, 11 pi over 6, you can see that it's 4 and almost a half. So as you go around these angles from pi over 2 to pi, cosine is negative, so it comes back on the circle here. And then as you go around from pi to 3 pi over 2, that's also negative cosine, so it reflects back over here. So it actually hits the circle twice as you move from 0 to 2 pi. Here, let me zoom out again just to show you a little bit better. Now what I did was I did y equals 5 cosine x on a rectangular graph, and then y equals 3 plus 5 cosine x on a rectangular graph. So obviously that just moves everything up 3 is our transformation. Now notice that if I have just cosine and an amplitude of 5 without moving up, it perfectly reflects over the x-axis. Real quick, what I meant to say there was it doesn't reflect on itself, but I kind of flipped it around just from pi over 2 to 3 pi over 2, and you can see if you make a horizontal line, it just goes across it again, and I don't know. I just felt like I needed to explain that a little bit. Could flip this around, and it reflects over itself. But with y equals 3 plus 5 cosine x, notice that only a little bit of it goes negative, just this little part right here. And so if I flipped it around, it would not look the same. It would not go up as high. So if we look at just even 0, 5, and then 8. So here, if I look at angle 0, here it is 5 and then 8. So angle 0 is 5, then 8. If I come back over here and I look at pi over 2, pi over 2 is 0 for 5 cosine of x, but it is 3 right here for 3 plus 5 cosine of x. So let's go look at pi over 2 over here now. So pi over 2 here is 0, but then it's 3 right here. So it's 0 here and it's 3 right here. It moved up 3 on the rectangular grid, but it's moving out 3 from where it was here. So everything has kind of a space of 3 if you think about it. It doesn't look like proportionally it does because of the way it's circular, but it really is. If you go out radially, if you go out each angle, you'll see that from the distance from here to here is 3, the distance from here to here is 3, and so on. But what explains it going into quadrant 2 here, where it didn't go into quadrant 2 with just our 5 cosine theta? Well, when we had 5 cosine theta, remember that as we went around, it reflected back on the circle itself. So here, let's look at, for instance, that angle is 2 pi over 3. I should write that in there. So this angle right here is 2 pi over 3. And so if I look on my rectangular grid, 2 pi over 3 is right here. And it's right there for the 5 cosine theta, and it's right there in the positive area for the 3 plus 5 cosine theta. So here it was negative and reflected back on the circle, and here it stays positive. So it does not reflect back on itself in that area because it moved up. I don't know if that makes any sense, but in my mind it does. So if we come back over here again, we've got the loop to talk about. Well, if you look at pi, here's pi. And before it went to -5, which it just, again, mimicked itself because it went -5 and 5. But for pi, now it only goes down to -2. However, the graph goes all the way up to 9, so it does not go on itself again. So if I come over here for the polar coordinates, there we go. I think it's a little bit easier. I don't know if you can see the whole thing. But for the polar coordinates then, when I go out to pi, it only goes to -2. It does not go all the way back out to 9 here. So that's why there's a little loop inside right here. And then also if you look at that angle right there, zoom in on it. What is that? Oh, 5 pi over 6, of course. 5 pi over 6. So this part right here of the graph is the loop inside itself. So let me go back over here. So this part right here is that part that goes below 0 on the rectangular graph. On the, again, 5 cosine theta, it just reflected back on itself, but on the 3 plus 5 cosine x, it loops in on itself. The next one I want to look at is y equals 6 plus 5 cosine x. So that much, the 6, moves it up above the x-axis at all times, so it stays positive. So looking at our key points here, at 0, it is up here at 11, and at pi, it's at 1, and then at 2 pi, it is up here again at 11. And so it never goes negative. So looking at our polar now, so remember that the r 5 cosine theta, it repeated on itself. If you were looking at an angle in quadrant 2, it went negative and it went right back on the circle. Well, for r equals 6 plus 5 cosine theta, we're only going to have positive r's. 5 cosine theta is never going to go below 0. I mean, sorry, 6 plus 5 cosine theta is never going to go below 0. So it comes around like this and kind of makes a little divot right there at pi. Let's see what's going on there. So at pi, it's at 1. And then at 5 pi over 6, let's zoom in here. 5 pi over 6, it's about 1 and a little bit more. So yeah, 1 and a little bit more. So it takes on this really odd shape like this, where we don't go into the negatives. So it just sits right there. It does not go through 0, 0. Interesting. And that is because the 5 cosine theta, its domain, it goes from -5 to +5. But again, with the 6 there, 6 plus that, it is always positive. So the domain is always positive for r6 cosine theta. So just relating those graphs. Hope that helps a little bit. Okay, here I have 5 plus 5 cosine theta. So this moved the graph up 5, which means it only goes up to 10. It touches 0 and then goes back to 10. So it's not going to be negative. Then we don't have a loop inside, but it does touch 0, 0 this time, where the 6 plus cosine or 6 plus 5 cosine x didn't touch 0. So over here, that's where that shows. Here is 5, and then if you add 5 to it, it goes out to 10. So on all of these angles that radiate out, it is going to be 10 away. And right here is though where you would be repeating back onto the circle if it was r equals 5 cosine theta. But like I said, it doesn't go negative. So it would just be like this, and it actually does hit 0, 0.